All right, lesson 3-1, solving systems of equations. So by the time we're done with this lesson, we should be able to solve a system of linear equations by graphing, substitution, and elimination. So to start off, a system of equations is when we have two or more equations with the same variables. So an example could be something like y equals 3x plus 5 and y equals negative 1/3 x plus 2. So we need at least two equations, but we could have as many as we want. So they just need to have the same variables. And the form that the equations are in doesn't matter. So if I wrote this in standard form and this one was in slope-intercept form, that part doesn't matter. So we just need at least two for it to be considered a system. And when we're looking at this little kind of big curly bracket tells us that these go together. Now, depending on the resource that you're looking at or even the tests and quizzes that you receive, you might not see this symbol. But if you do, that's just telling you that these equations go together. Now, when we are solving a system of linear equations, we're trying to find the ordered pair that satisfies all equations. And this really is just talking about the ordered pair that makes both equations true when we substitute in that point. Okay? So we're really looking for the intersection point, so where the lines meet on a graph. That would be considered the solution to the system. Now the first method that we're going to talk about is solving by graphing. So if we are going to solve by graphing, we do want our equations to be in slope-intercept form. So that means that we want it to be in y equals mx plus b. So that's the easiest form to graph in. We graph each equation, and then we're going to find our point of intersection, and then write that coordinate as our answer. Okay. And when we are graphing by hand, it is best to use graph paper so that it's easy to tell where your intersection point is. Otherwise, your lines might not be evenly distributed, so your answer could be wrong. So when we're solving by graphing by hand, make sure that we have graph paper handy. So we're just going to start with these three examples. Here's my graph paper. Okay. So again, our first step should be to make sure that our lines are in slope-intercept form. And for my first problem, they are. So we can just start graphing those. So the first one I'm going to do in purple. So if we graph that, we're going to start up at 3. So 1, 2, 3. Here's my point. And then our slope is -1, so we go down 1, left or right 1. And we just kind of want to put as many points as we think we might need to be able to find the intersection. So you might have to go back and add points to make that easy to find. And then my next equation, I'm going to do this one in green so that we can see it a little bit better. So again, we're going to start down at -2, so -2. And then our slope is 3/2, so we're going to go up 3 over 2. And notice how I ran into another point. So that point right there is my intersection. Now you don't have to do this, but I'm just going to kind of circle it. So this point right there, that is our intersection point. So we're just going to figure out what that is. So from our origin, we're going right 2 up 1. So that would be a point of 2, 1. And that would be our answer. So the solution to our set. Okay, so answer is 2, 1. All right, if we take a look at the next one, so we should notice that this is not in slope-intercept form. So that's the first thing that we want to do. So we're going to solve that top equation for y. So I'm going to start by subtracting the x over. So that would give us -2y equals -x plus 4. And then we would divide everything by -2. So y equals +1/2 x minus 2. So that's the line that we want to graph this time. So I'm going to go down 2, put my first point. And we have a slope of 1/2, so up 1, right 2. And again, how many points you decide, maybe go the other direction too, it's kind of up to you. So we just want to make sure that we put enough so that it's easy to find our intersection point. So again, sometimes we might have to go back and add more. Alright, so second equation, also looking at this one, this is not in the form that we want it in. So I'm going to have to solve this one for y. So this one we're going to subtract the 3x. So we'd have y equals negative 3x plus 5. And since y is by itself, then we can start graphing. So we're going to go up 5. 1, 2, 3, 4, 5. Slope is negative 3, so we're going to go down 3, right 1. Okay, looks like I found my point of intersection. Okay, so again, I'm going to circle it to make it a little bit easier to see. So this point right here is where they are intersecting, so that's going to be my solution. So again, if I'm looking at this, we're going right, 1, 2, and then down 1. So our point is 2, negative 1. Okay, so again, this is the ones that we graphed. It's equivalent to this one. And then our solution is 2, negative 1. All right, one more just for practice. So again, we want to start by solving our equations for y. So that top one, that means I'm going to start by subtracting the 9x over. So 3y equals negative 9x plus 15. And then divide everything by 3. So y equals, and we would have negative 3x plus 5. Okay, so again, we are going to start up at positive 5. 1, 2, 3, 4, 5. And then we are going down 3, right 1. And connecting those together. And then the second one, again, we want to solve that one for y. So what I'm going to do is I'm just going to add my y to make it positive, and I'm going to subtract 7 at the same time. So if we do that, we're going to have y equals x minus 7. So that means I'm starting down at negative 7. 1, 2, 3, 4, 5, 6, 7. I have a slope of 1, so I'm going to go up 1 over 1. So it looks like I'm going to have to go back to my first line and add a couple more points. So again, our slope was negative 3. So I'm going to go down 1, 2, 3 over 1. So you can also see here my line was actually a little bit off because I didn't graph this point. So this is where they're going to intersect if I add in this line right here. So this is why it's important that we're using graph paper and to go back and continue our dots if we need to. Okay, so that would be my answer. So we went 1, 2, 3 to the right, and then down 1, 2, 3, 4. So 3, negative 4 is the answer for this one. Okay. So again, this was our equivalent system. Answer was 3, negative 4. So that's where our two lines intersected.